Phase changes. Um, Under this module, we'll talk about the uh, change of phases, mainly from the solid to liquid, liquid to gas, the conversions between those three main phases: gas, liquid, and solid. Actually, the changes of the phases occur with the temperature changes. How that would happen? Yes, what would actually change during this phase change? Yes, the motion of the molecules will change depending on the temperature change. The whether it the molecule how they would behave when the temperature when the heat was absorbed or when the heat was released, how that the motion of the molecules changes. The when you look at this summarized the phase changes the diagram, you will see the processes between the different phases. All the processes shown with the blue arrows are exothermic processes. During those processes, the heat is released to the external environment or to the outside. The processes which are indicated by the red arrows are endothermic processes. These processes absorb heat. As an example, when it change, a solid is changed into a gas, the heat is absorbed, and that process is known as sublimation. When the liquid is changing to solid, the heat is released. It's an exothermic process. Yes, you need to know the names for these processes, and you need to know whether it is going to be an exothermic process or an endothermic process. How do you think whether it's you don't need to memorize. Look at the structure of a solid and look at the structure of a gas. Where do you have strong intermolecular forces? Yes, the solid is a compacted structure. In a solid structure, we have stronger intermolecular forces. So, if we change the solid to a gas, gas has the weakest intermolecular forces. So what we should do? Yes, we need to break the strong intermolecular forces in the solid to make it to a gas, to change it to a gas. So if we want to break that strong intermolecular forces, we need to give the energy in. That's an endothermic process. It absorbs. That process needs energy. uh, or in other case, liquid to solid. Yes, liquid is just the has the weaker intermolecular forces. Solid has strong intermolecular forces, and giving or changing back to a more compact structure. So it releases heat during that process. Just think about that way, and then it would be easier to remember whether it's going to be an endothermic process or an exothermic process. Here you will see the two different curves. What would happen if we cool a sample of gas all the way, change back to a solid? The lines. The diagonal lines indicates the temperature changes. The flat lines indicate the phase changes or the equilibriums. The heat involved in those the here diagonal lines, so the temperature changes can be calculated by using the MC delta T equation. M is the mass, C is the specific heat, delta T is the temperature change. The flat lines, the heat involved in the flat line can be calculated by that the heat of molar heat of that for that process and times the number of moles. So if it is the change from the gas to liquid, the process is the condensation. So then that would be the molar heat of condensation, like that. So if it is going to be heating, then it is known as the heating curve. So first, the we imagine we are heating a sample of solid. Temperature is rising up until, okay, what is this temperature? Yes, that is the melting point. Temperature of the solid sample is increasing until it reaches the melting point. At the melting point, a phase change occurs from solid to liquid. We don't see any temperature change during the phase change because it's in equilibrium and solid is changing to the liquid. After all of the solid change to liquid, then we have only liquid here, then the temperature will started to increase again. It comes back to another temperature where we don't see any change after that. That is the boiling point. Now the phase is changing from the liquid to vapor. The process is boiling or the vaporization. So during the heating curve, it is the process it would be the endothermic. During the cooling curve, all the processes are exothermic processes. So if it is endothermic process, the change of heat must be greater than zero. If it is an exothermic process, the change of heat must be lower than zero. These are the specific names that we use for those the phase changes. The molar heat of fusion, heat absorbed by 1 mole of solid when it melts to give liquid at constant temperature and pressure. Like that, molar heat of vaporization and molar heat of sublimation. Here we talk about the evaporation. That's the process of changing liquid to the vapor. The rate of evaporation is it depends on the temperature, surface area, and the strength of intermolecular forces. Here in your right hand side, you will see a picture of the it represents the kinetic energy of a sample of molecules, and here this is the average kinetic energy of the sample. And if this is the barrier, or if that is the minimum kinetic energy needed by a molecule to escape from the surface of the liquid to the vapor. Yes, there is always a particular amount of molecules that have the energy, higher kinetic energy than that minimum kinetic energy that a molecule must have to escape to the vapor phase. Yes, this is there is always a sample of molecules can reach to the vapor phase, but the majority doesn't have that the minimum kinetic energy. So what would happen if we increase the temperature? Yes, if we increase the temperature, then more molecules can absorb that the heat, and now a larger portion of the molecule have that kinetic energy above that or more than that minimum escape kinetic energy. Then we have more molecules in the vapor phase than in the lower temperature. Here, this is the lower temperature portion, and this is the higher temperature portion. Here, uh, it compares two samples of molecules. Here we have a smaller portion, we have a larger portion. So only a few amount can escape from the liquid to vapor phase. What we can say? Yes, they have stronger intermolecular forces and they need a higher kinetic energy. So the B evaporates slowly.